Hi, welcome to my channel. So in this video, I will show you how to prove trigonometric identities. Now, proving trig identities means making the both sides of the identities to be the same. So there are particular ratios that we use to make them to be the same. So for example, if you want to prove this one, of which we're going to do in this video, it means we have to make this part look like this, or we can make this part to look like that using the ratios that we're given. And there are so many ratios that are there. There are about 6 of them, and then in those 6 there are also some ratios that are there. So it's up to you now to look at which side you want to make look like the other, and then you look at what you are given. Will you determine which trigonometric identity you are going to use? So among them, we have what we call tangent and cotangent identities. We also have reciprocal identity. We have negative angle identity, Pythagorean identity. So what I can say is that feel free to Google about those trig identities, stick them on in your room, so that each time you look at them, you'll be able to memorize them, and then you're able to go in an exam having them. All right, having mentioned all of that, let's get to business. Prove tan theta plus cot theta that they are equal to sec theta times cosec theta. So among the identities that I've mentioned, we have what we call tangent, that is tangent and cotangent. Okay, identity. Now on this one, it says that tan theta is equal to that is sine theta over cosine theta. Then cot theta, that is cotangent theta, is equal to you just flip these two, and then it goes to cos theta over sine theta. So what we're going to do in this video is that we want to make the left side of this to be equal like this one. Feel free to start with either way that you want. I can tell you that of course some of the times you're going to get stuck along the way, so when you get stuck, leave it, try the other side, and then make it to be make it look like the other side. For example, if you started with the left side and then you get stuck along the way, just leave it and then try the right side, so that you make it they look like the left side. So for us, just try with the left side and then make it look like the right side. So now under cotangent and tangent and cotangent identity, we have these ratios. They're so lot. They're about 4, but these are our focus now. So we're going to rewrite this part here, but where there is tangent theta, where there's tan theta, we're going to replace it with sine theta over cosine theta, and then where there is cotangent, we're going to replace it with cosine theta over sine theta. So let's go ahead and write it. So tan theta, here we are going to write that is a sine theta over cosine theta. Then here it's plus, right? Yeah, plus cot theta. This is cot theta here, which is cosine theta over sine theta. And then from here, what we need to do is the simple addition of fractions there. So how do we do them? We look at the common denominator, which is cos theta times sine theta. So what is cosine theta into cosine theta times sine theta? It will be sine theta, isn't it? Then sine theta times sine theta, it will be sine squared theta plus. Then this one into this one, so this and this will cancel each other, so remain with cosine theta. Then cosine theta times cosine theta, it will be cosine squared theta. All right, so we have something that looks like this now. Now, if you remember, under Pythagorean identity, under Pythagorean identity says that sine theta or sine squared theta plus cosine squared theta is equal to 1. So it means that the whole of this part here, it's equal to 1. So we are applying again another identity here. So on this part now, this one can be written as 1 over this one there, which is cosine theta times sine theta. All right, we have something like that now. So what next? We have already used that is tangent and cotangent, then we have used Pythagorean. So now let's go ahead and use another type of identity, which is a reciprocal, so that we replace these ones with their ratios. So under reciprocal identity, so step by step, under reciprocal identity, for sine, it says that sine theta is equal to 1 over cosec theta, and then cosine theta is equal to 1 over sec theta. So let's go ahead. These are just one of them. There are about 60 here. So let's go ahead and plug these ones into this. So where there is sine, we're going to put 1 over sine theta, 1 over cosec, and then where there is sine, we're going to put, where there is a cos, we're going to put 1 over sec theta. So we have, allow me to use this one as a division sign. So on this part, we're going to say 1 divided by, what's this? Cosine theta. This is the one here. 1 over sec theta. This is division, right? Oh, is this times, sorry. So times sine theta. This is sine theta, which is 1 over cosec theta. 1 over cosec, which is cosec theta. All right, this is theta, sorry. Oops. So from there now we have 1 divided by 1 times 1, that is 1, right? 1 over sec theta times cosec theta. We are going to have sec theta times cosec theta times cosec theta. Okay, we are here now. So what next? We're going to simplify these, and we know that when simplifying, we just this one is the same as 1 over 1. Then when we make this one a multiplication sign, this one will go on top there, and then we're going to get the reciprocal there. So we have a 1 over 1 times, this one will go on top here to be sec theta. Okay, cosec, I know, you know that there is a multiplication sign here, cosec theta, then over 1, so that this one into this one, they will cancel each other to just 1, isn't it? So 1 times 1, it's 1. 1 into 1, it's 1. 1 times this one, it is cosec. So it's sec theta, then cosec. Let me just write it in full now. Cosec theta, that was a CS, C there. So this is what we found as our answer. So is it true? Let us go back to our question and see whether it is true. Remember, we are working with what was on the left. Now this is what we found finally. So let us compare this one with what was in our question, or what is on the right there. So we found that it is sec theta cosec theta. What is in our question? Our question says prove that tangent theta plus cotangent theta is equal to sec theta plus cosec theta. Have we proved? Let's check the answer. The final answer, sec theta times cosec theta. So you say hence, is it proven or proved? Hence proved. So remember, there are so many of them about these ratios, so it's up to you now to look at what you're going, which part you're going to start with. So if we wanted to make the right side to look like the left side, we would have started, of course, looking at the reciprocal identities. But since we started looking at the left, and where we had tan and cotangent, that's when we looked at the tan and cotangent. I hope you like this video. Comment what you think about this video, and if it's the first time that you're watching this video, please subscribe to this channel, and of course share this video to your friends. Until next time, bye bye.